Hi, and welcome to this Microsoft Virtual Academy course on SQL Database Fundamentals. I'm Graham Malcolm from Microsoft, and I'm joined with my colleague Chris Randall here. Chris?
Hi, I'm Chris. I'm a senior content developer with Microsoft, or as we say around here, same as Graham.
Yeah, exactly. Yeah. So there's a slide that we're showing here with some information about Chris that tells you a little bit about his background. There's a very nice picture of his dog as well. If you're confused about that, Chris is the one on the left. And there's also a rather nice slide with me looking kind of cool and relaxed, which is not really how I normally feel.
No, well, I couldn't find one with sunglasses, so that's why I picked the one with my dog.
Yeah, I never get enough good weather for that. So that's us. That's pretty much all you need to know about us. Really, the important thing that we're going to talk about today is we're going to talk about working with databases. So we're going to spend a little bit of time just giving you a kind of introduction to databases and some of the concepts. It should be pretty interesting. All right, Chris, you want to lead us through what we're going to talk about?
Sure. So this course is broken out into half a dozen modules, such as this brief introduction, which will roll right into our getting started with tables. We'll talk about the structures of database tables and where they live and why you need them. We'll talk about how to get data into them, how to get data out of them, how to make changes. And then we'll move into sort of the system support for databases. We'll get into topics like indexes and other things that are used to optimize databases. We'll talk a little bit about different data types that are native to SQL Server and relational databases, and then we'll move into non-relational database and other types of data that we might store. And then we'll finish up with a brief look at the kinds of things that a database administrator, or a DBA, performs on a regular basis. Graham?
All right, yeah, that sounds like a pretty packed schedule. So as you see, let's roll right on in there and start with an introduction to what databases are and what kind of things we can do with them. So I guess when people think about data, a lot of people who are familiar with working with tools like Excel, for example, probably think about something that looks a bit like this. You might think of data that looks like a table of data in something like Excel. So
widgets and thingy-bobs and knickknacks.
Widgets and thingy-bobs and knickknacks. So you can imagine that somebody who's keeping track, perhaps you're a small company, perhaps you're just keeping track of some stock, you might do something like this. Now, technically, I guess you could say that's sort of a database. There's certainly data there.
Well, Excel is the world's most popular database, isn't it?
Indeed it is. Excel is the world's most popular database. It's perhaps not the most efficient way to store that data. So I want to kind of walk through some of the limitations of storing data in a table and in a spreadsheet like that. So let's take a look at some examples here. So here's that data in a table form. We're taking it out of the spreadsheet here. We've just got that same table of data. Can you see anything that's perhaps a bit funky about that, something that's not great?
Well, I'm looking at that column for color, and I'm seeing that there's multiple values in a couple of those rows. We've got blue and red for thingy-bob. We've got red and black for knick-knack.
Right, exactly. So I mean, obviously the intent here is that thingy-bobs are available in blue or red. So for color, we've stored two values in that one column. Now that's not ideal. We really want to be storing just one value in each column. So what we want to do is go through a process. Technically, the process is called normalization. You won't be quizzed on that later, so don't worry too much about that. But we're going to use a process called normalization. And the first thing we need to do is put this data into what we call first normal form, is the technical term. And what that really means is we shouldn't have any columns that have more than one value in them. So let's take a look at how we do that. And we'll just animate this table. You can see there's the columns that are problematic. We've got those double values in there. So what we'll do is we'll just split those out, and we've now got separate rows. So we've satisfied first normal form. Each column supports only one value. But there is still kind of a few problems with this. And I'm looking particularly at the supplier. What can you see there that might be an issue for me?
Well, I see some redundancies. I see the same supplier stored in multiple rows. We've got Contoso 3 times, Northwind twice.
Exactly, yeah. So we've got data there that's stored in multiple rows, as you say. It's duplicated. And of course, that means if I ever had to change, if Northwind changed their name, I'd have to actually go and change it in each of the rows where it appears. And that's pretty inefficient. And I'm using up more space than I necessarily need to store the data. So at this point, we want to move into what we call second normal form, where we start separating those values out into separate tables, and each table represents an entity in my database. So I can go ahead, I can see there's the problematic column. I can go ahead and I can split that out, and now I've got a product table and a supplier table. And I've assigned a unique ID to each supplier, I've assigned a unique ID to each product, and I'm using the ID for the supplier in the product table to say, hey, this is the supplier for this product.
And we could even do that with some of the other columns, couldn't we? We could do that with color.
Yep, absolutely. We've got the same problem with color. So we can go ahead and we could do that. And again, we split that out. So we've now got our color table and we've got our product table. Now, we're not quite there yet. There's a few other issues we need to deal with here. So let's just have a look at this problem here. We've got the color ID and we've got the product ID, but there's nothing that says which color is which product. All right, so we have a bit of an issue there. Now, there isn't really a business entity that we can use to deal with this, but we can create a table. Effectively, it's a table that just enables the join. It's a nice, efficient way of saying, here's a table that joins the product table to the color table, kind of intermediary table.
So it maps between them.
Yeah, a mapping table is a good way of thinking of that. So I've now taken my data that was originally just a table in Excel, and I've split it out into multiple tables, and I've joining them based on keys. So it's beginning to look much more like what we would think of as a relational database. There is still another problem. Can you spot the other problem here?
Well, if we go back to the original product table, we don't see a connection, do we? Let's see. We've got product to our color. We don't have product and supplier.
We don't have, well, we've got the supplier.
That's true. We do have that directly in the column.
I'll give you a hint. Does a product have a phone number?
No, nor do phone numbers have that many digits, but we'll give you a pass on that.
We'll ignore that for the time being. But products don't have phone numbers.
That's right.
So we've got phone in there, but that really isn't related to a product. That's actually something to do with the supplier.
Right.
So we have this concept of making sure that all of the columns in a table depend on the primary key for that table. They all depend on what that table is about. So in this case, products don't have phone numbers. Really, that whole column should be moved across to the supplier table because suppliers have phone numbers. And in doing that, we reduce a bit of redundancy as well because we've now got the telephone number for each supplier in the supplier table. So this is now in what we call third normal form. Now, there are a whole bunch of other higher level normal forms we could go into and wax lyrical about. We don't need to do that. For our purposes in a database, usually third normal form is pretty much as far as we need to go. But what we've now got is a database that consists of multiple tables with keys that identify uniquely each row within each table and foreign keys in the other tables that we can use to relate one table to another.
And we've removed redundancies.
Yep.
We made it easier to update. Is it any faster to query?
Not necessarily any faster to query. In fact, in some ways, it's going to be more complicated now because we're reading from more tables. So later on in this course, we're going to look at ways that we can optimize queries for dealing with these tables. But for the time being, we've now reduced the redundancy. We've got a pretty efficient way to store our data. So we can think of what we've done as being creating the database, what we'd call the schema of the database, effectively the tables that are in the database. We need to think about how that database is actually stored. And what we do is we take that and we store it on disk in something called a database management system. So it's on a server, really. Typically in an organization, there's a computer that's the server, and it's running some software that's a database management system. And examples of that are things like SQL Server. Microsoft SQL Server 2016 is our latest version of a database. There's also the option to perhaps connect to that database from various different clients over a network, which is typically how people access them. And of course, that may not even be on the same local network. It may be in what we call the cloud. It might be hosted on an internet service somewhere like Microsoft Azure. So I could have a virtual machine in Azure that's running SQL Server, or I could use something like an Azure service. There's Azure SQL Database, which provides me with a database system in the cloud. So we've got this idea of having the data stored in that schema on disk in a database system that's accessed over the network from various different clients. Make sense?
Sure.
So one of the things we might want to think about when we're accessing that is, of course, some sort of security. So typically, if we're accessing something in the internet, not necessarily just on the cloud, even internally on a network, you might have something called a firewall that limits the clients that can actually connect to it. And you'll certainly want to have some sort of identity check, some sort of authentication that makes sure that people are connecting who are allowed to connect, and that anybody who isn't allowed to connect is forbidden from getting to it. So there are some other considerations that we need to think about, and we'll talk about those later on when we look at the admin of this. But that's kind of how the system works. Well, now that we understand a little bit about the concepts behind this, we know a little bit about database schemas, we know a little bit about the way a database server works, why don't you jump in the driving seat and actually show us how we can see a database being created and managed?
Sure. Let's take a look at the demo.
In this demonstration, we'll take a look at a couple different ways to create SQL databases and review the initial configuration. For this demo, I'm going to get started with Azure SQL Database. And the reason I'll do that will be clear, I hope, because it's going to take a few minutes for it to run in the background, and I can cut over and show you how to create databases in SQL Server Management Studio for on-premise databases or virtual machines. So let's start here at the Azure portal. I've logged in with my Microsoft account. I'm looking at my dashboard, and I'm going to create a new Azure SQL database. And there will be a number of decisions you'll need to make, and this course isn't designed to go through all of those decisions and all of those configuration options, but you'll get a flavor of what's involved. I do want to commend you to some of our other MVA programs on Azure SQL Database. So I'm going to go ahead and specify that I want to create a new database. And I'll go to Data and Storage, and I'll choose SQL Database. And the blade will open where I can start the configuration. I'll be asked for a name. It'll populate with my subscription information, and there'll be other information I'll change as I go. So one of the most important things, of course, is going to be the name of the database, because that's going to be used by every application and perhaps every ad hoc report user that's going to be connecting to this. So I'll give this hopefully a clear name. We'll call this MVA Fundamentals Demo, and I'll use my Azure subscription. Azure offers a couple of different ways of deploying SQL databases. I'm going to take advantage of the fact that I've made these before, and I'll use an existing resource group to make it easier for myself to clean up. I've got a resource group called MVA Demos, but as you get deeper into Azure, you'll find that there are a number of resources that get created just in the process of creating a virtual machine or a SQL database or other items, and resource groups are a nice way to keep them together and make it convenient to manage. All right, well, I want to create a new database, and Azure gives me the opportunity here to either start from scratch with a blank database, to use one of the samples available, or even to restore from a backup of another SQL database in Azure. I'll start with a blank database. I'm then asked what logical server I want to put this on, and I have the ability either to choose from one of my existing logical servers, or I can create a new server and walk through that whole process. For the purposes of this demo, I'm going to keep this fairly straightforward. I'll use one of my existing servers, but I do want to point out that if you're going to create your own new server, you will need to configure firewall rules to enable you to connect to it, and you will need to provision an administrator account. All right, so let's go ahead and walk down through my choices. Now, what pricing tier do I want? This is a much longer discussion than we're going to have right now, but in a nutshell, a pricing tier is a way of bundling a performance level in something we call database transaction units. And it's a combination of compute resources and storage resources and some other features that enable us to control how responsive this SQL database is going to be. For the purposes of this demo, I'll choose a P1. We'll see that's going to give me up to 500 gigabytes of storage. It's going to automatically include geo-replication and point-in-time restore. There are a whole long list of these pricing tiers. And again, I encourage you to hit the Azure documentation to learn the differences between them if you're going to be using Azure SQL databases. I'm also going to be asked about a collation, and a collation in brief is a combination of character set and sort order, which will drive how things like your applications will communicate with the database. I'll leave my default here, my SQL Latin 1 General Code Page 1, case insensitive ascending sort. That's my default here in the US. When I'm done with this, I'll want it to be pinned to the dashboard of the portal just for convenience. That doesn't really have anything to do with creating a database, but it will make it easier for me to find it and show it to you. All right, well, I'll go ahead and click Create. And it says, hey, if you made any changes in some of the other blades, we're going to get rid of them. That's fine with me. And I'll see a message here that says that I am submitting the deployment to the server. That's going to take a few minutes, so I'm going to let that cook in the background. And in the meantime, I'm going to switch over to SQL Server Management Studio, which I have connected to a local instance here on my laptop. So let's put the portal away for now, and let's bring up SQL Server Management Studio. And here in SQL Server Management Studio for SQL Server 2016, I've got a connection to my local laptop here, which is called Shoal. I am logged in as myself, and I've given myself, during installation, I've given myself administrative privileges. But one of the things you want to make sure you do when you install your own SQL Server is make sure that you also create an account that has permissions to access it, and for that first account anyway, permission to do things like create databases and so forth. So in this view of SQL Server Management Studio, I have a list of what databases are available to me on this particular instance. And as we mentioned in the presentation, an instance is essentially a running copy of SQL Server. You can have multiple instances on one machine based on what the resource load is going to be and how much performance your machine has. And on this instance, I have several user databases. There's an old sample here called AdventureWorks 2016 CTP3, and then a couple of samples that I pulled down from Microsoft.com that are the new samples for SQL Server 2016. In this interface, I have access to the databases and the objects within them, everything from tables and views and the service broker settings and security settings. But I've also got access to system-level features such as system-level security. Who's allowed to log into this instance? What are they allowed to do when they get here? And so on. For the purposes of this demonstration, I simply want to set up a database and make it ready for future demos. So I'm going to start by generating a script from one of the existing databases and reviewing its results. So using a feature of SQL Server Management Studio, I'm right-clicking on Wide World Importers. I'm going to specify that I want to script it out as a create operation to a new editor window. Now I could script this right to a file on disk, I could script this to my clipboard and so on. But let's use a new query editor window. And we'll see a lot of T-SQL has been generated here. And we're not going to walk through all of this, but I do want to show you some of the critical things that are part of creating a new database in SQL Server. So I'll walk through and I'll highlight certain key things as we go. And if you're interested in more of the other options, I encourage you to take a look at MSDN and Books Online, and I encourage you to take a look at some of our other courses. So the first thing this script had to do was to switch to the master database, which is a system-level configuration database. And then we'll see comments, which are these bits in, well, they were in green before I highlighted them in yellow, but we'll see those are T-SQL comments. And that's simply documenting what's being scripted at any given point when the script was generated. And now we get to the good part, the create database statement. So that's our key, and there are many, many options, but we're going to focus on the core ones here. So we'll say create database, and we'll give that database a name, such as create database wide world importers. At a minimum, that's all you need to do. SQL Server comes with a number of default settings, and we'll take a look at some of those when we create our own database in a few minutes. But at a minimum, that will then put the data files and transaction log files for this database in the default locations for that particular server instance. It will have a default size and other default settings. But let's review some of those settings that are available to us. So create database wide world importers. We'll skip containment for now, but that's a security feature for later. Then there's a setting here for what file group it's going to be using. Then this is going to be one called user data. We'll talk more about that in a more advanced course. But the key thing here is that we're specifying that this database has a file that we're going to give a nickname or a logical name of WWI primary, and the actual file is going to be located in my file system. Now that is a default location, and we never recommend that you place your user databases in that default location. And once you're in an environment with a SAN, for example, you'll be placing your data files on that SAN. But I've got just a developer laptop here, and I'm putting things in local locations that aren't going to live forever, so I'm not terribly worried about the locations. However, just for comparison's sake, let me just show you what I've done here for my own databases. On my C drive, I've created a folder called SQL Data. I'm trying to zoom in so we can see it. And I've just, on my SQL Data directory here, I've created some folders here for data, transaction logs, and backup. And then I've marked those as the default for this instance so that as I add new databases, they will by default be placed in those locations. And we'll take a look at how that goes. All right, let's get back to SQL Server Management Studio. So one of the things we need to do to create a database is we need to specify where the files are going to go. And at a minimum, you'll start with two types of files in a SQL Server. You'll start with a data file. And so if we scroll all the way to the end of this long path, we'll see that we're creating a data file called wideworldimporters.mdf. MDF is just a convention for the extension. There's no requirement that you call it that way, but that's what most of us tend to do so that other DBAs looking at our work can understand what they're seeing. And as I mentioned, there are defaults for lots and lots of things, but you can also specify things like what the starting size is going to be, whether it can grow, and if so, how much, and what that growth increment should be. And these we get into in more advanced developer and administrative courses, but just understand that there are a number of things you can do to control that, and we'll take a look at them a little later. So we'll create an initial data file. There's some other files here that this particular sample is using I'm going to ignore for now. And we'll also specify then that we need a transaction log. And so we're creating something here called WWI log. And again, it's got a long path and file name here to create a file called worldwideimporters.ldf. And that transaction log file is so important to SQL Server because of the way the SQL Server engine writes changes from memory down to disk and records a history of those actions in the transaction log. So to create a database at a minimum, we're going to want a data file, and we're going to want a log, and we're either going to specify our own settings, or we're going to allow the defaults to kick in. And for the purposes of our discussion here, the rest of all of these settings are simply ways of recording in the script what the DBA who created this database did in setting it up. So let's take another approach to this. If I go back to my Object Explorer, and I right-click on the Databases folder under my instance, I can click on New Database, and I'll get a dialog box with some choices very similar to what we've just been looking at, such as what do we want to call our new database? Where do you want the data file to go and what should it be called? Where do you want the log file and what should it be called? And a long list of options, many of which were recorded in that script that we just looked at. So let's take a straightforward starting approach to creating a new database, and I will call this MVA demo local DB, as opposed to the cloud database that I've got running in the background right now. And I will review then the logical names for the files that will be created, so MVA demo local DB and MVA demo local DB log. We'll see that this is going to be for data rows, and this is going to be for transaction log items. We'll see it's creating a default primary file group. We can specify our initial size in megabytes. So let's just go 500, for example, and an initial size for the log. I'm not going to do a lot with this database, so I don't need a lot of storage to record changes. We can, if we want, get into auto growth settings. We'll talk more about those in other courses. And then finally, we can choose where we want these files to go. And I don't want them to go under C program files, so I'll go ahead and select that folder that I showed you earlier, which was on my C drive, SQL data, and this is going to go in the data folder. And my log is going to go in my logs folder. And because I'm working on a laptop that only has a single drive, I really can't show you best practices such as putting the data file or files and the transaction log on separate disks or separate units in a SAN. This is as close as I can get, but it'll help sort of plant that seed that we want our databases and our logs in separate locations for performance and to some extent for fault tolerance. All right, and then finally I'll be asked to give these names, and if I leave it blank, it'll just name it after the logical name, so I'm simply going to leave it blank. And at this point, again, I could review other options and to add file groups for adding additional files. I won't do that for this particular database. If I'm ready to go, I can just click OK, but before I do that, let me go ahead and tell this to take what I've done here and script this out to a new window, so that when I click OK, while we're waiting for the engine to build that database, we can go and review what instructions it was just given. So there's my T-SQL, create this database, and that primary file group is going to be that file called MVA localDB.mdf on my C SQL data folder. Same idea with the log, the initial settings I'd created, and then all of those other options that we don't have the opportunity to get into right now. But we've now got a database. I'm going to close this without saving because I know I had asked the Management Studio to create that for me. And I would expect now to see my database here in the list of database. And sure enough, there is MVA demo local DB. And we'll see in SSMS here, Management Studio, the containers here where we'll then be able to get in and do things like add tables and so forth, which we'll get into later in this course. So in this part of the demo, we've gone ahead and created a brand new database. We can connect to that database and start writing queries with it, adding objects, And we'll get into those things as the course goes on.
All right, fantastic. So you've shown us how to get started with the database at least.
Yep.
I guess what we probably want to do is just recap some of the key points that we've covered in this.
Sure.
module.
What do we talk about?
Well, the first thing we said was that databases are used to store data in tables. So this idea of normalizing those tables out. So we normalize them to create a relational schema for the database. The tables are stored on disk. There's all sorts of weird and wonderful stuff happening underneath that. We talk about pages being stored on disk, but fundamentally the tables are stored on disk and they're managed in something called a database server. And client applications will access that database server across a network typically. Increasingly, that database server, rather than being what we call on-premise, is in the cloud. We see them hosted in cloud services like Microsoft Azure. And the access to that database is generally restricted using a combination of firewalls to prevent individual machines from accessing it that shouldn't access it, and authentication to make sure that the users who are accessing it are authenticated.
And we'll talk more about configuring firewalls and authentication, and even beyond that into authorization and encryption and all sorts of good security stuff later in the course.
Exactly. Oh, welcome back. We're in Module 2, and we're going to now start looking at working with tables in our database. So that should be interesting. Let's have a look at that.
Let's go.
So we'll start by looking at how we create a table. And most operations that we do in a database, we do using a language called SQL. And we're going to do this using a SQL statement, and it's the create table statement, unsurprisingly. So we're creating a table, and the table name in this case, we're giving it a name, and the name's in two parts. So tell me a little bit about that.
Well, the two parts include the schema, which is really a container that holds the table itself, and then the name of the table. So sales is our schema, and product will be the name of the table. We can put other objects inside the same schema. Related tables can all be in that sales schema, for example. We'll talk more later about things like views and stored procedures. They can all be stored in a schema. So it gives us a way to organize and then later use for a security wrapper as well.
All right, so it's a sort of namespace, but also something I can use as an encapsulator for security. All right, so we're creating this table. Now, when I create the table, you can see the diagrams appeared above there. There's a table now. It's a fairly amorphous thing because a table consists of columns. So actually, we need to start defining the columns that are in that table. So in this case, I'm defining a column called product ID. Each column has a data type. So what's the type of data I can store in that column? And in this case, I've said this is an integer column. So whole numbers only in this column. It's a special kind of column called identity. And what that means is it's going to automatically increment the value in that column. So you'll quite often see this used as a way of generating a unique key for a row in a table. So we've got an identity column, and we've explicitly said this is the primary key for this table. In other words, this is the column, the value in this uniquely identifies each row in the table.
And only one column can have that identity property, right?
That's right, yeah.
Within a given table. And similarly, only one column can be the primary key unless you've got a composite of multiple keys. But you can't have different columns that are each the primary key.
Yeah, there's only one primary key. It consists of one or more columns, I guess, is the way to think about that. You could combine columns to make a primary key. So we've got our product ID column. The next column we're going to create something called a name column, and it's of type varchar20. Now let's kind of interpret that a little bit. Varchar?
Varying with characters.
Varying with characters. So in other words, it's a string value. It's a string of characters, and it can vary. Some will maybe only have, some people might, or some products in this case might have names that are only 5 characters long.
Sure.
They can have any number of characters up to 20. We specify a maximum. And then we got this column called price, which was specified as a decimal value. And I've also included the word null there. So tell me a little bit about nulls.
Well, in this case, that allows the column to be null, which is to say we may not supply a price for one of the rows, and that may be because we don't know what it is or because it doesn't have a price.
Right, so we're basically saying we're not enforcing there being an explicit value in this column. We can have a null value that says either there is no price or we don't know what the price is. So we create our table with these 3 columns there. We've got our product ID, our name, and our price. And what I might want to do is, after I've created it, I might want to alter that table and perhaps add an additional column. So we've got this create table statement to create a table, and an alter table statement is used to modify the definition of a table. We're not modifying the data in the table, we're modifying the table itself. So I'm altering the table, and in this case, I'm adding another